Welcome to the Network and Cybersecurity lecture series. Myself, Darshan BD, Assistant Professor, Department of ECE, SJB Institute of Technology, Bengaluru. The Network and Cybersecurity subject code is 17EC835. This subject is professional elective for 8th semester students. In this subject, we are going to study the network security concepts and also a cyber security concept. It consists of 5 modules. First 3 modules covers the network security concept and another 2 modules covers the cyber security concept. Module 1 is transport level security. In that we are going to discuss web security consideration, secure socket layer, transport layer security, HTTPS and secure shell protocols. First, considering the web security consideration, in that we are going to study web security threat and different web traffic security approaches. In secure socket layer, we are going to study the secure socket layer architecture, secure socket layer protocol stack and secure socket layer record protocol operation. Then we are going to study the chain cipherspec protocol, alert protocol and handshake protocol operations. In transport layer security, we are going to study the hash function and some cryptographic function. Next, hypertext transfer protocol for secure. In that we are going to study the connection initiation and connection closure operation. Next, secure shell is called as SSH. In that we are going to study SSH protocol stack. Consider alert protocol. The alert protocol used to convey secure socket layer related alerts to the peer entity. Moreover, each message in this protocol consists of 2 types. One is the first byte takes the value warning and or pattern to convey the severity of the message. If the level is pattern or severity, the secure socket layer immediately terminates the connection. Means if anything happen in that particular connection, if anything patterns occurs, anything warnings occurs in that particular connection, means immediately it's going to terminate the connection. The other connection on the same session may continue, but no new connection is established. Means whichever the connections is already established, that connections will continue, and so new connections will not establish, and whichever the connections is having problem, so immediately it's going to terminate the connection. The second byte consists or contains a code that indicates the specific alert. Considering list of alerts that are always fatal, definitions from secure socket layer specification. Concerning unexpected message, an inappropriate message was received, bad record MAC, an incorrect MAC was received. MAC is nothing but message authentication code. Third one is decompression failure. The decompression functions received improper input, means so decompression failure happens means it's not able to decrypt the original message. In that time, so decompression will be failure. Unable to decompress or decompresses to greater than maximum allowable length. Fourth point is handshake failure. Sender was unable to negotiate an acceptable set of security parameters given the options available. The last one is illegal parameter. A field in a handshake message was out of range or inconsistent with other fields. Considering some more alerts are the following: close notify, no certificate, bad certificate, unsupported certificate, certificate revoked, certificate expired. Cursor close notify notifies the recipients that sender will not send any more messages on this connection. Means close notify this happens means so in that particular connection no communication will be happen. Each party is required to send a close notify alert before closing the right side of the connection. Once the connection is established, so when you are going to close that connection for a particular connection, you need to notify or you need to send the close notify information. No certificate may be sent in response to a certificate request if no appropriate certificate is available. Consider the bad certificate. The received certificate was corrupt. Concerning unsupported certificate, the type of the received certificate is not supported. Certificate invoked. The certificate has been revoked by its signer. Concerning the certificate expired, the certificate has expired. Means so these are the some signals when going to occur this one is going to send the alert message. Certificate unknown. Some other unspecified issues arise in processing the certificate. Handshake protocol. Considering some handshake protocols, message type and the parameters. In that message type, we are going to consider the allow request message, client allow, server allow, certificate, server key exchange, certificate request, server done, certificate verify, client key exchange, and finish. These are the different message types that we are going to use in the handshake protocol. The parameter we are going to consider is the allow request is null. If the client allow information, the version, random, the session ID, cipher suit, and the compression method. Consider server allow. So for that also we are going to consider seal. Consider certificate chain of X509V3 certificates. We are going to consider server key exchange. Server key exchange is nothing but the parameters and the signature. Certificate request is type and authorities. Consider server done is null and certificate verify is a signature. Client key exchange consider parameters comma signature. Last one is finished. Finished is a hash value. So these are the secure socket layer handshake protocol message types. This handshake protocol allows the server and clients to authenticate each other to negotiate an encryption and MAC algorithm and cryptographic keys. So we are going to negotiate an encryption and MAC algorithm, encryption algorithms and message authentication code algorithms, and also a cryptographic keys. The handshake protocol is used before any application data is transmitted. Means these handshake protocols we can call it as a control signals. So to establish a connection, we are going to use this handshake protocol signals data. So always handshake protocol is used before any application data is transmitted. Considering the handshake protocol that consists of a series of message exchanged by client and server. So considering all of these in the following figure. A handshake message has the following format. It consists of three messages. Type 1 means it's having 1 byte. Next is length, it consists of 3 bytes, and content, it consists of bytes. That it indicates one of 10 messages of ancient protocol. Second one is length, the length of the message in bytes. Third one is content, the parameters associated with this message. The initial exchange needed to establish a logical connection between client and server. The exchange can be viewed as having 4 phases. Phase 1 is establish security capabilities. Second phase is server authentication and key exchange. Third phase is client authentication and key exchange. And fourth phase is finish. Concerning that phase 1, phase 2, phase 3, phase 4, here we are going to consider the different operations so that we are going to consider in the next slide. Phase 1, establish security capabilities. This phase is used to initiate a logical connection and to establish the security capabilities that will be associated with it. The exchange is initiated by the client, which sends a client allow message with the following parameters. Consider the parameters are version, random, session ID, cipher suit, and compression method. In the version, the IS secure socket layer version understood by the client. Second one is the random, a client generated random number which serves as the nonce. Session ID, a variable length session identifier. A non-zero value indicates that the client wishes to update the parameters on an existing session. A zero value indicates that the client wishes to establish a new connection on a new session. Cipher suit, in that cipher suit we are going to consider a cryptographic algorithm. Okay, so this cipher suit consists of the cryptographic algorithm. In that cryptographic algorithm concerning the key exchange, encryption, and message authentication code supported by the client in decreasing order of preference. Compression method, this is a list of the compression methods that client supports. After sending the client allow message, the client waits for the server allow message. Means the client sends the allow message and it waits for the server's acknowledgement. The parameter contains the value which client had sent to the server and the server had chosen to use, that we are going to consider. So in phase 2, server authentication and key exchange. Okay, in this phase, so we are going to provide the authentication of the server to the client. So in that we are going to consider a certificate. So server sends a certificate. So if we need to authenticate with the client, so in that we are going to consider server sends a server key exchange message which contains the list of secret keys going to use for the encryption purpose. Then the certificate request message, so it includes the 2 parameters, certificate type and certificate authorities. So here the certificates are used to authenticate the server and the client. The final message in the phase 2 is that server done message. Okay, so when you are going to complete that the connection, so you are going to send that the server done message. So this message is sent by the server, so it indicates that it's end of that server. That after sending the server done message, the server will wait for the client response. So this message has no parameter, we are not considering this message. Only the server sending that the server done message, and it's going to take the acknowledgement from the client. Consider in this figure, you can consider here client is there and server is there. When you are going to send information, so before that the client's going to send client allow message. Once the client allow message is received at the server end, so server going to acknowledge for that, server going to send server allow message. That is happen in the phase 1. In the phase 2, so client and server both going to authenticate that. For that, the server going to send the authenticate message. Then, so whichever the secret key that you are going to use for encryption, so that the server key exchange will be happen. Next, certificate request. So is server going to send the certificate message to the client, then server key exchange also it's going to send, then server certificate request is happens. Means server asking the certificate from the client, then it's going to send server done message. That server allow done message means is going to close that, means so server sending the server done message, then it's wait for the acknowledgement from the client. So in that time the client is going to certificate to the server. In the phase 3 is going to send certificate to the server 3. Same way the client key exchange will be happen, then certificate verify will be happen. So once its certificate request is happen, certificate is going to send when it's going to verify that certificate verify. These things will be happen in the phase 3. In the phase 4, change cyberspec, then the finished. Change the cyberspecs is going to exchange it. So client is going to send change cyberspec and finished. So meanwhile the server is also going to send change cyberspec and finished. So that thing is happen in the phase 4. So phase 4 shows that change cyberspecs suit and finished handshake protocol. So as we have discussed in the figure, in the phase 3, the client authentication and key exchange will be happened. So in that time, so client is going to send the certificate to the server. So it's going to send the client key exchange, and also it's going to acknowledge for the server certificate. Means in the previous phase, server had sent the certificate to the client, so that it's going to verify that, so it's going to send the acknowledgement as certificate verified. That things will be happen in this slide. Phase 4 is finish. This phase completes the setup by secure connection. So here the exchanging, both client and server is going to exchange the cyberspec messages, change cyberspec messages. So here we are going to consider the client send the change cyberspec message and copies and pending cyberspecs into current cyberspec. So here considering that cyberspec message, here there are cyberspec protocol having 1 byte of information. Then the client then immediately send finished message under the new algorithm keys and secret. So considering that, we are going to consider two hash functions, MD5 and SHA. That so in the MD5 we are going to use master secret, the pad2. The MD5 we are going to use handshake messages at the sender, master secret and pad1. Consider SHA. So here we are going to use means secure hash algorithm, master secret the pad2, secure hash algorithm, handshaking messages, the sender and master secret of pad1. So this is the hash function, the format which we are going to use it in the phase 4, that is to finish the connection between the client and the
server. The server, at the end, the server sends its own cyberspecs message, transfers the pending to the current cyberspec and send it finished. Okay, we are going to consider at this point. So handshake is complete, means handshake is the control signals. So exchanging the control signals from the client and servers are finished at this point. Thank you.